For our first mathematical example, here is our first question. Miguel pulls a wooden sled with a force of 65 newtons east. Carla pulls the same sled with 40 newton 25 degree north of east. And Paulo pulls it in the opposite direction with 30 newtons 10 degrees south of west. Compute for the resultant force acting on the sled. So now we will need to find the resultant force of the sled.
Draw a table X, Y, A, B, and C. First, Miguel pulls a wooden sled with a force of 65 Newton east. Dahil ang east ay nasa x-axis, sa x natin ilalagay ang 65 Newton. Dahil walang degree na binigay sa given, automatically 0 na ang y natin. Next, B. Carla pulls the same sled with a 40 Newton and 25 degree north of east. To solve x, use CA. Cosine equals adjacent over hypotenuse. So, isasolve natin si adjacent para makuha si x. So, multiply both sides sa hypotenuse. Cancel out na natin yung hypotenuse. And then, ang matitira na lang ay hypotenuse cosine equals adjacent. Substitute lang natin. 40 cosine 25 is equal to 36.25. Ang value na x ay 36.25. Next is solve for y. Same process lang din pero so ang gagamitan natin. Sine equals opposite over hypotenuse. Cancel out lang si hypotenuse, then substitute. The value of y is 16.91. The last one, letter C. Paulo pulls it in the opposite direction with 30 Newton and 10 degrees southwest. Ito-draw ang triangle ng south of west, 10 degree ang angle, and 30 naman ang hypotenuse. Same formula and process lang din tulad sa B.
After we've computed for the x and y's a to c, we must now find the r. So to do this, we must add the x a to c and the y a to c. So first, we must find the x r. So 65 plus 36.25 plus negative 29.54. So our answer is 71.71. And for the y, let's add 0 plus 16.90 plus negative 8.21. So for our answer, we have 11.69. Now, to get our resultant force, we will now use the formula of r equals square root of x squared plus y squared. So we will get r equals to square root of 71.71 squared plus 11.69 squared. And we will get the answer of 72.66 newtons. So, to get our resultant angle, we will use the TOA method, which is tangent opposite over adjacent. So, to our calculator, to get our angle, we will use shift tan opposite over adjacent. In this case, shift tan 11.69 over 71.71, and we will get the answer of 9.26. And the direction it is facing is north of east. Now we have the final answer, 72.66 newtons, 9.26 degrees north of east.
In question number 2, Luis pulls a cart with a force of 55 Newton north. Mia pulls the same cart with 45 Newton 30 degree east of north. And Jake pulls it in the opposite direction with 25 Newton 55 degree west of south. Compute for the resultant force acting on the cart. To solve this vector problem, we first set our directions. North is positive y, east is positive x, south is negative y, and west is negative x. Louis pulls with 55 newtons straight north, so his force is simply Rx equals 0, Ry equals 55. Mia pulls with 45 newton at 30 degrees east of north. Since the angle is measured from the north axis, the north or y component uses cosine, while the east or x component uses sine. This gives Rx equals 45 sine 13 degrees is equals to 22.5 east, and Ry equals 45 cosine 30 degrees is equals to 38.97 north. Jake pulls with 25 newton at 15 degrees west of south, so both components are negative. We get Fx equals 25 sine 15 degrees is equals 6.48 west, and Ry equals 25 cosine 15 degrees equals to 24.15 south. Adding all x components, we get 16.02, and adding all y components, we get 69.83. To find the resultant, we use the Pythagorean theorem. R equals square root 16.02 squared plus 69.83 squared is equals to 71.6 Newton. For the direction, we use the tangent formula. Theta equals tangent raised to 1 multiplied to 16.02 divided by 69.82 is equals to 12.9 degrees east of north. Therefore, the resultant force acting on the cart is about 71.6 Newton, 12.9 degrees east of north.
In question number 3, Arvin pulls a rope with a force of 60 Newton west, Bianca pulls the same rope with 48 Newton 35 degrees north of west, and Chris pulls it in the opposite direction with 32 Newton 20 degrees south of east. Compute for the resultant force acting on the rope. So now, we proceed in vector diagram that shows the forces applied on the rope by Arvin, Bianca, and Chris. First, we set the coordinate system. The x-axis points east to the right and west to the left, while the y-axis points north upward and south downward. Now, let's plot each forces in graph.
Now, we break them into x and y components using cosine and sine. For force A, it only has an x component, which is negative 60 newtons, because it acts directly to the west, and that means our y component is 0. For force B, we use trigonometric relationships, the SOHCAHTOA. Cosine gives us the adjacent side, or the x component, and sine gives the opposite side, or the y component. So if we look at the figure, we are missing the adjacent and the opposite side. To look for the adjacent side, or the b sub x, we will use cosine. So b sub x equals cosine theta is equal to adjacent over the hypotenuse. We're going to multiply both sides by hypotenuse, and then cancel, and that leaves us with hypotenuse times cosine theta. B sub x is equal to 48 times cosine 35 degrees, because that's the given angle. So b of x is equal to negative 39.32 newtons west. So b sub y equals 48 times sine 35 degrees. B sub y equals 27.53 newtons north. Similarly, for force C, we will use SOHCAHTOA. C sub x equals 32 times cosine 20 degrees. That's our given angle for this figure. So C sub x equals 30.07 newtons east. For C sub y, we will use sine theta equals opposite over hypotenuse. C sub y is equal to 32 times sine 20 degrees. C sub y is equal to 10.94 newtons south. Step 3. Add the x and y components. For the total of x, we're going to add negative 60 newtons plus negative 39.32 newtons plus 30.07 newtons. And that leaves us with negative 69.32 newtons west. For the total of y, we will add 0 plus 22.5 plus negative 10.94 newtons. And that leaves us with 16.09 newtons north. For step 4, we will find the magnitude of the resultant using the Pythagorean theorem. So resultant is equal to the square root of x squared plus y squared. So we're just going to substitute. So the square root of negative 69.32 squared plus 16.09 squared. The answer will be 71.21 newtons. Step 5, we will find the angle using tangent. So here we can use our calculator, but press shift tangent 16.09 over negative 69.32. And that gives us about 13.47 degrees. For our final answer, the resultant force is 71.21 newtons at an angle of 13.47 degrees north of west.
Now, let's solve question number 4. We have a delivery driver who follows 4 legs. First, he drives 120 meters due west. Second, he turns and goes 200 meters due south. Third, he travels 90 meters on a road that is 45 degrees east of north. Finally, he goes 60 meters due east. We'll add the vector components now, using east as the positive x direction and north as the positive y direction. Now, leg 1 is 120 meters west gives x minus 120 while y is 0. Leg 2 is 200 meters south gives x 0 and y minus 200. Now leg 3 is 90 meters at 45 degrees east of north. That direction has equal east and north components. So each component is 90 times cosine 45 degrees, which equals about 63.64 meters. So leg 3 gives x plus 63.64 while y gives plus 63.64. Now leg 4 is 60 meters east. It gives 60 plus on x while y has 0. Now we will add the x components. Minus 120 plus 0 plus 63.64 plus 60 equals plus 3.64 meters. So the net eastward component is 3.64 meters. Now we will add the y components. 0 minus 200 plus 63.64 plus 0 equals minus 136.36 meters. So our net southward is 136.36 meters. Now that the total displacement vector is therefore 3.64 meters east while the south is 136.36 meters. To get the magnitude, we use the Pythagorean theorem. The square root of 3.64 squared plus 136.36 squared, which equals about 136.41 meters. The direction is almost due south, tilted slightly to the east. The angle is about 1.53 degrees east of south. Now we have the rider's displacement. It's approximately 136.41 meters, bearing the south 1.5 degrees east.